So in today's video we have to solve this problem, and the solutions we are looking for are the real ones. This problem is from an IIT JEE sample paper, but this problem is also common on the internet. Many people have talked about it in the videos named "You should be able to solve this." As you can see, we have numbers 4, 6, and 9 in the base of each of these exponential terms. Whenever I encounter a problem like this one, my first step is to try to put all of those bases in the terms of prime numbers, using the canonic form of a natural number. So I can write 4 as 2 squared. I can write 6 as 2 multiplied by 3, and I can write 9 as 3 squared. Let's plug all of this into our equation. Then it becomes 2 squared raised to the power x plus 2 multiplied by 3 raised to the power x, and that is equal to 3 squared raised to the power x. What we can do at this step is to use the rule that a to the power b and that all raised to the power c is equal to a raised to the power b multiplied by c. Of course, this is equal to a to the power of c multiplied by b, which is a to the power c, and that entire thing raised to the power b. We are going to use one more rule with this one, and that is that a multiplied by b raised to the power c is equal to a to the power c multiplied by b to the power c. By using these rules, I get that our equation here is equivalent to the equation 2 raised to the 2x plus 2 to the power x multiplied by 3 to the power x is equal to 3 raised to the power of 2x. At this step, you can try a couple of things. Of course, I'm going to show you some things that are not going to lead us to a result, but that really doesn't matter. When you are trying to solve a mathematical problem like this one, the important thing is that you take the problem which you have and to play with it, and then step back and think about it, and then come back to it and play with it even more. And eventually you will come up with a solution. And if you don't, you can always consult the literature. But never just go blindly to consulting the literature without thinking about the problem yourself first. That way you are going to just sit down and learn problems in mathematics by heart, and when you get a real problem which you don't know how to solve, you are never going to be able to solve it on your own. You are just going to look at someone else doing the problem and copy their solution. That is not a productive way of doing mathematics. So let's try a couple of things here. So the first thing that comes to mind is a formula for a square of the sum. So a plus b squared is equal to a squared plus 2ab plus b squared. As you can see, a squared term is going to be played by this 2 to the power x, and that is going to be squared. Remember, this 2 can go outside using this rule here. Now we can transform our equation. We can write that it is 2 to the power of 2x plus 2 to the power x multiplied by 3 to the power x minus 3 to the power 2x is equal to 0. This minus sign here is going to make us a little bit of a problem. It messes our attempt. Of course, you can write that 3 to the power 2x minus 2 multiplied by 3 to the power 2x to get this. And then you can attempt to get something useful that way. But that is really an unnecessary complication. Let's change our approach to this problem. So this attempt has failed. Let's disregard it. Let's try to make a constant number 1. So we have our equation here, 2 to the power of 2x plus 2 to the power x multiplied by 3 to the power x is equal to 3 to the power 2x. So from this equation we can make a constant 1 in a couple of ways. Let's do it this time by dividing an entire equation by 2 to the power of 2x. That way we get that left side of the equation is 2 to the power 2x plus 2 to the power x multiplied by 3 to the power x divided by 2 to the power 2x, and the right side of the equation is 3 to the power 2x divided by 2 to the power 2x. Well, when we simplify all of this, 2 to the power 2x divided by 2 to the power 2x is 1, and we have plus the second term is 2 to the power x multiplied by 3 to the power x and divided by 2 to the power of 2x. This 2 to the power 2x, that is 2 to the power x multiplied by 2 to the power x, and you can cancel out this 2 to the power x, and you are left with 3 to the power x divided by 2 to the power x. So this is then equal to 3 squared divided by 2 squared, and all of that to the power of x. So at this step it becomes pretty obvious what we are going to do. Let's approach to this right side of the equation and write it like 3 to the power x divided by 2 to the power x. So we have the same term, and then we can leave the square to be here. So by doing that, our equation is 1 plus 3 to the power x divided by 2 to the power x. It is equal to 3 to the power x divided by 2 to the power x and squared. So this is a simple squared equation. Let's introduce a substitution here that some variable y is equal to 3 to the power x divided by 2 to the power x, and then our equation gets simplified into 1 plus y is equal to y squared. Well, this is pretty easy to solve. With this substitution, our equation just gets transformed into a quadratic equation. As you can see, all that is left to do here at this point is to solve this quadratic equation which we have. Of course, the quadratic formula is ay squared plus by plus c is equal to 0, and y1 or 2 is equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a. A is equal to 1, B corresponds to negative 1, and C corresponds to negative 1 as well. So let's plug in all of this information, and we get that y1 or 2 is equal to 1 plus or minus the square root of 1 plus 4 divided by 2. So that is 1 plus or minus the square root of 5 divided by 2, and we get finally our two solutions, 1 plus the square root of 5 divided by 2, and the second solution is 1 minus the square root of 5 divided by 2. Now remember that our substitution was y is equal to 3 over 2 raised to the power x. So this 3 over 2 to the power x, that is going to be larger than 0 for all x's which are real numbers. And we are trying to solve our equation only for real numbers. So this solution right here, y2, which is 1 minus the square root of 5 over 2, that is smaller than 0. And it doesn't make sense when you're trying to solve the equation for real numbers. This is going to produce complex solutions. We are going to throw that away, and the only solution that we have now is that y1 is equal to 1 plus the square root of 5 divided by 2. And if you recall, this here, 1 plus the square root of 5 over 2, well, that number is a special number in mathematics. We call it a golden ratio. So to solve this for x, we are just going to return the substitution. So 3 over 2 to the power x becomes 1 plus the square root of 5 over 2. We can solve for x this equation simply by taking a natural log from an entire equation. So this is ln of 3 over 2 to the power x. It is equal to ln of 1 plus the square root of 5 divided by 2. So if you remember, ln of a to the power x is equal to x multiplied by ln of a. So we are going to use this rule, and we get that x multiplied by ln of 3/2 is equal to ln of 1 plus the square root of 5 over 2. So that makes x to be ln of 1 plus the square root of 5 over 2 divided by ln of 3 over 2. And this is our final solution right here. So thank you for watching. Please support my work by subscribing to the channel, and I recommend that you watch this video next.